Hi everyone, welcome to my YouTube channel. Today we are learning the fractional knapsack problem. It is similar to 0 or 1 knapsack, but with one key difference. As you know, in 0 or 1 knapsack problem, we could either take the item or not. We weren't able to take it partially. But in fractional knapsack, we can take the item partially since the items are divisible, which is totally changing the solution. So instead of exploring many combinations as we did in dynamic programming, in this one, we simply rank items by how valuable they are per unit of weight and then fill the capacity from best to worst. Where can we use it? We can use it in budget allocation, for example. We can split a budget across multiple projects where partial funding yields proportional value. Or we can use it for CPU allocation, where we can divide a limited resource among tasks where partial allocation provides proportional benefit. In fractional knapsack problem, for each item, we are first finding their density value. It will actually give us how valuable that item is, considering its weight. So in order to find this density for that item, we are dividing its value by its weight. And right after finding density for each different items, we are ranking them in descending order, so that the starting point of our list will be the highest one. Then we will fill the capacity from best to the worst one. And while filling the knapsack, we are looking if that item can be fit. If the item can fit as a whole, then we are taking the whole item. If it doesn't fit, then we are taking the fraction that can fit and stop. This maximizes total value because at every step we prioritize the most valuable weight we can carry. Then let's write the algorithm together. First of all, we are sending items and capacity as our parameters. So, for each item, I from 1 to n, where the n is the number of items, I will compute the density. After computing the density for each item, I will sort all items in descending order of density. So, sort all items in descending order of density. So actually that means that highest value per weight will be the first element. Then I will initialize my variables. By the way, since we are not using any specific programming language, since this is just a pseudoalgorithm, we don't need to follow any specific rule. So we can write what we want. We don't need to follow anything. Let's initialize my variables. First, I will have a variable called total value. I will use it to accumulate the items values that we are selecting. Then I will have another variable, which is remaining capacity. And I will initialize it as capacity. It will decrease gradually. And I am initializing an array which will hold the percentage of each item we are taking. In the beginning, I will say 0 for each item I. Then I will loop through the sorted array. So, for each item I in sorted order, do the followings. If the weight of I, the weight of that item, is less than or equal to the remaining capacity, as you remember, we have initialized it here as the capacity. If the weight of that item is less than or equal to the remaining capacity, that means that we can take that item as a whole. So I will say that the fraction of that item is 1, since we will take that item as a whole. And right after that, I will update the total value and remaining capacity. I will update total value, which will increase by the value of that item, the value of I, and I will also decrease the remaining capacity by the weight of that item. However, if the weight of that item is greater than the remaining capacity, that means we can't take this item as a whole. So we need to divide it. We need to get a fraction of it. So in order to do that, we need to calculate the fraction first. Fraction of that item. It will be the remaining capacity divided by the weight of that item. The weight of that item. And now that we have found what percentage of that item we should add, now we need to update total value and remaining capacity again. However, since we are only taking the fraction of that item, since it is not fitting in the remaining capacity, now we are only taking leftovers, so the remaining capacity is going to be 0 after that phase. And that means that we can't add any new item. So we need to get out of the loop. First, let's update total value and remaining capacity. We will add the value of that item to the total value. However, we need to multiply it with the fraction. And as I said, since the capacity is full now, we can't take any new item, so the remaining capacity is going to be 0. And now that the remaining capacity is 0, since we can't take any new item, I need to get out of the loop, which I will say break the loop. So that means that the table is full now. And finally, I will return the total value, which will give us the maximum profit, the maximum value we can get, as well as the fraction table, which will say us what percentage of each item we are taking. Now let's walk through the algorithm again in order to understand it better. Okay, first we are computing the densities. Then we are sorting these densities in descending order. And we are doing it greedily, considering the best value per weight first. So the first item of the list will be the highest one. Then we are initializing our variables. First we are initializing our total value as 0, then remaining capacity as capacity, and we are also initializing our fraction array, which in the beginning it will only include zeros. And then we will iterate through the sorted array. And for each element we will look if the weight of that item is less than or equal to the remaining capacity. If it is the case, then that means that we can take that item as a whole. We don't need to take fraction of it. And we are updating total value and remaining capacity. However, if that item's weight is greater than the remaining capacity, that means that we can only take the fraction of it. We are calculating the required fraction, and again, we are updating the total value and the remaining capacity, and now that the table is full, we are breaking the loop in order to get out of the for loop. And finally, we are returning our total value as well as the fraction array. And this is it for this video. I hope you like it. Thank you for watching. If you have any question, leave a comment. Thank you. Have a nice day. See you.